Hello everyone. So today I'm going to tell you something about knapsack DP, and we can start with the simpler questions like LIS, longest increasing subsequence and longest arithmetic subsequence of the knapsack DP. Now generally nothing is different. I have thought of making another playlist, but then I can include this in this playlist only. So now what is the knapsack DP? It's nothing but uh, taking current choice based on previous choice. I could say taking current choice based on previous choice and then maximizing it. Mostly the questions will be like of the maximization only. Okay, so like longest, shortest. It wouldn't be shortest, it's longest only. Knapsack TP focuses on the maximizing part. You have learned some greedy questions related to knapsacks. Like, okay, you have been given two, or I say four bags, and four bags have, let's say, weight of 3, 2, 1, and 5. And the cost of taking each of the bag is, let's say, 1, 3, 4, and 8. Now you want to increase this weights after taking, but your cost should be reduced. So you have to find maximum weight you can take with the reduced cost. Okay. So so it's like a questions wherein whether to take this or not depends on your previous, like, okay, whether you have taken this previous one, you've used this weight or not, and then you will decide whether to take the current one or not. Okay, so basically, I would say the current choice always depends on the previous choice which you have made, and the answer mainly lies with the maximization part on it. Okay, so the simpler question is LIS. LIS is nothing but longest increasing subsequence. Okay, so let's say you are given 2, 4, 1, 3, 5, 7, 9. So what is the longest increasing subsequence? Okay, 2 and 4 increasing, but then 1 decreased that. So I'll start from 1 again. 1, 3, 5, 7, 9. Oh, this is fully increasing. So my longest increasing subsequence has length of 5. So I have to return that length. What is the length of the longest increasing subsequence? Now there are so many ways, there are more optimized ways also, but mostly this kind of questions, okay, this longest increasing subsequence, longest arithmetic subsequence, wherein you mainly have two loops involved. Okay, so your current index or current value is, let's say, I. Okay, and your previous index which you have to see is from 0 to I minus 1, which I'll call it as j. Okay, so you will go from all index from 0 to I minus 1, and you will check that whether I have taken that. If I have taken that, and if I will take this I, what will be my length of the longest increasing subsequence? So with this type of questions, bottom up approach, okay, will be easier rather than top down approach. So your bottom up approach means tabulation approach will be more easier to apply over here than the recursion approach. So we will move to tabulation approach with this type of questions. Not for all knapsack DP questions. Okay. In tomorrow's video, I'll try to cover some questions related to prefix sum, maximization sum part, given two arrays and all. So that will go to 2DDP kind of questions. Okay, and that doesn't involve, that is again knapsack kind of questions, but then that does not mean that you have to do it specifically with bottom up. There also bottom up is easier to understand, but top down is also not hard. Okay, both are equivalent to understand, and we can do it from any of those, both of those, like whatever you want. I'll try to explain both of those for a particular question, and then we can go ahead. Okay. Maybe 2DDP I can cover with a separate playlist. Okay. If you want, let me know in the comment section like what will be comfortable. But LIS and LAS are those kind of questions which could be with the single DP only. Okay. It's a single DP only. But then it will be easy when you do it with the bottom up approach by looping in the tabulation form. Okay, so our simple question is like, okay, we have this array 2, 4, 1, 3, 5, 7, and 9. Okay, what we will do? Now we have one DP of size n for sure. Okay, And what will be our DP of I state stores? Now, as this is bottom up approach, okay, I'll have longest increase length of longest increasing subsequence from 0 to I, not from I to n, from 0 to I only, because from 0 to I will be stored in I, and I'm checking of the previous ones and calculating the current ones, so it's based on 0 to I. Okay, and finally your DP of n is your max answer, which will be length of longest increasing subsequence from 0 to n for sure. Yes? Okay. Fine. So initially, longest increasing subsequence will be 1, the number itself. So initially, we have put for every of this as the 1. I could make it n plus 1 size. Okay. And now what I can do is, I can start from I is equal to 1 and I can go till I is less than n and I plus plus, and I have to go for j is equal to 0 till j less than equal to I minus 1, or j less than j less than I and j plus plus. Now, every time what you have to do, your DP of I will be initially 1 only, right? That means from 0 to I, or ending at I could say. Okay, is 1 initially, which we have put already. So my DP of I could be that value only, like whatever is there, or or it could be 1 plus, if I will take that j value, it could be 1 plus DP of j. But when can I take this value? When can I take this value? If my current or my previous number is less than my current number, then only it's the longest increasing subsequence, right? J value should be lesser than ith value, and then only I can do this. Otherwise, DP of I is DP of I only, so no need to do that. Okay, it will remain as it is. Okay, if the J value is lesser than I value, then only you have to compare it with DP of I, 1 plus DP of J. Okay, I hope you are clear with this. Fine. Now there is another optimized approach for this. Okay, what is the optimized approach? Now let's say I have make an array. Okay. Now this is my array 2, 4, 1, 3, 5, 7, and 9. Now what I'll do is I'll insert 2 first. Okay. Now I got 4, which is I'll see my I have make a new array. Okay. I what I'll do. This is the bind. Okay. The above one will take the order of n square time complexity. You know that. Okay. Now what this one will do? This one will try to do in n log n time complexity using binary search. Okay. So what this does is, but this is applicable only when to find length. Only to find length. This approach would be needed when you want to find the sequence also. Let's say now I wanted to find the sequence. Like, okay, what is the sequence? Then I can store the previous value along with the DP value, along with the DP array. I'll store the previous array also. Like, okay, when I'm going with 1 plus DPJ, that means I'm going to I by taking the value until jth point. So my previous of I is like j. So I have received to this I value from the jth value, I could say, right? From the jth value. Okay, fine then. I'll store this previous values. Okay, I'll start from the previous value of nth number. I'll take that number, I'll go to its previous. I'll take that number, I'll go to its previous until the value of previous and the number itself is the same. And we have got the sequence in reverse order. We'll just reverse it and return it. I hope you got that. Okay, but if you just want to find the length in a little more optimized time complexity, what you can do is, let's say you have taken 2. Now you'll compare 4 with the 2. So 4 is of course greater than 2, so I can push that in my newer array. Okay, now comes 1. Okay, now 1 is not greater than 4, so I'll find the place of 1 using binary search. Now, how can I find the place of 1 using binary search? Like, if I wanted to put 1 in the sorted order, where should I put 1? Of course, before to the 2. So, what I need to do? I need to find the upper bound of 1, which means something greater than 1. Okay. And I'll put it to the place which is in ahead of that. So, I'll put at that index my 1. Okay. So, that means That means that I'll find the upper bound, or you can find the lower bound also. Lower bound will return that value if it is present. Okay, it will find that value if it is present. And upper bound, so you can find lower bound. Sure, okay. You have to find the lower bound. So I'll find the lower bound for 1. 1 is not present, so it will return me this index 0, something which is greater than 1. Okay, so it will return me index 0. So I'll remove this 2, and instead of 2 I'll add 1. Now comes 3. So the lower bound of index 3 is not present. So it will give me index 1. So I'll remove 4, and I'll insert 3 over here. Okay. Now comes 5, which is greater than 3. So 5 will be here. 7 greater than 5 and 9 greater than 5. So what is the length of my newer array? 5. So that is your answer. This is the more optimized way. We could take another example, shorter example like 7, 2, 4, 8, 3. Okay, so I think 248 is our longest increasing subsequence. We have initially entered 7. Now 2 is not greater than 7. So I'll do the lower bound and I'll get the index 0. So instead of 7, I'll place 2 in my newer array. Now 4 greater than 2, so I'll insert it. 8 greater than 4, insert it. 3 not greater than 8. So I'll find the index of 3 with the help of lower bound, which I'll get instead of 4. So instead of 4, I'll place 3. So what is my length? Came 3. So length is correct. But the new array sequence 238 is not correct. 2 here, 3 here, 8 here. No. Sequence is not correct. So for sequence finding, this is not correct approach. But for finding of just length in the optimized manner, it could be done with n log n. So you just need to run one loop from I0 to n. And for each value, if it is greater than the last value, just insert it. Otherwise, with the help of lower index, with the help of lower bound, find it index and then enter it. And finally, the length of the newer array is your answer. Okay, so let's just quickly solve the question of the longest increasing subsequence. Okay. We'll do it with a normal approach only, n square as of now. So I have n as nums dot size, and I have dp of size n plus 1. What I can do is I could make vector of and dp of size n plus 1 with 1 everywhere. Okay, or I could make of n also, it's okay. I'll start from I is equal to 1 till I less than n, I plus plus, and with j0, j less than I, j plus plus. So if if nums of j is lesser than nums of I, okay, then dp of I is equal to max of dp of I, comma 1 plus dp of j, and we will return dp of n for sure. Sorry, it should be in -1 now. Okay, I hope you are clear. Now we'll move to another kind of question, which is the longest arithmetic subsequence. Longest arithmetic sequence or subsequence. Okay, I will take another color. Okay, so what this type of question says that until now you have to just find the longest increasing subsequence. Now you need to find arithmetic subsequence, means difference between every consecutive numbers should remain same of your sequence. Okay, so like you're given 1, 2, 5, 10, and 15. So there could be two possible sequences like 1, 2 with difference of 1. I cannot add 5 or 10 anything with this. Okay. Or I could have 1, 5, okay, 5, 10. Any two though I can of course have. But my longest will be 5, 10, and 15. Length is 3 and the difference is 5. Okay. So this you need to return the length of the longest arithmetic subsequence. Now, what could be my first step to decide on the DP state or the changing variables? So, how many are the changing variables? You need to choose I, which is the index from the array. Okay. which we have done for LIS also. Like, okay, we are currently at which I, and we also need difference over here because we are not sure what is the difference. Okay, this goes under five difference group. This goes under difference group of 4. This goes under difference group of 5 again. This goes under difference group of 1. If I take 5 and 15, this goes under difference group of 10. So there are so many difference groups which you can make out of a single array. So this you need to define. So difference is like the difference of your arithmetic sequence. Okay. So now there are two ways. You can define 2D dp of I comma difference, which means that length of longest arithmetic subsequence from 0 to I with difference. Okay, with difference, this difference. Okay. And and another I could use is the map. We will see that later. Let's first go with the normal approach. Okay, now let's say I have defined this difference. Now your difference could be negative, could be positive, but we have to define maximum positive. So let's say my difference could be from minus 500 to plus 500. I'll make my difference as 1000. Okay, I'll add this side. So every time I'll add plus 500 to my current difference because I cannot store negative numbers in my 2D array. Okay, so just make sure this simple points which you need to realize while writing the code. Logic wise, it's okay. Okay, now we'll make a 2D array. Let's say I have make a 2D array of 1001 comma 1001. So this means my index could also go until 1000 and my difference could also go until 1000. It's minus 500 to 500, but let's take 1000 considering positive. Now what you have to do? Simple thing for I0 to I less than n. Initially it will be 0. Okay, with any of this difference, my longest arithmetic subsequence is initially, let's say, 0 from 0 to I. Okay, and initial answer could be 2. If I have considered this I and I have option for going from j0 to j less than I. Okay, 2 at least I can put, but no need of that. Anyways, we can calculate that. Okay, now what could be a difference between these two numbers? So this is my previous, that was my current. So this will be nums of j minus I plus 500. This is my difference. So what I'll store in my dp of I comma difference. Now it could be maximum of whether dp of I comma difference. I can keep it as it is if that is maximum, or 1 plus whatever is my j comma difference. Okay, because I got this j is the previous value. So from 0 to j with this difference. So let's say 5 and 10. So for 0 to j index, which is fourth index in our above question, okay, I got this length as 2. And now my 15. 15 by 10 is also 5 difference. So with the index ending at 5 and difference is also 5, 1 plus 2 will be 3 and dp of I comma difference is, let's say, 2 only. So I'll get my answer updated as 3. And every time what I have to do, every time I have to calculate my answer. I should not depend on last value like dp of n comma difference. Now what could be this difference? This could be anything, right? No, I cannot make sure that. So every time I calculate this dp of I comma difference, I need to update my answer value also with this calculated value to get what is my maximum answer I have got until now. Okay. But now you have realized that this is useful only for these differences which are coming in this array. Like, okay, it's useful for the difference of 1, 4, 10, 5, 5, 8. Sorry, 2 minus 10, 8. Okay, if I take 2, 10, 9, 1 minus 10. But it's not useful for 6, 7, or anything like such. Okay, can the difference be 6 of anything? No. Can the difference be 7 of anything? No. So those all are empty values, which for those all differences I'll get 0 values, of course, but that wouldn't be of use to anything. Okay, so that is like I'm wasting those spaces. So can I reduce this better in a better way? Like, okay, I got my differences from like minus 500 to 500. So can I traverse on my difference array? Traverse on difference values. Like, what are the possible differences I could get? I could get difference of minus 500. I could get difference until plus 500. So can I traverse for d is equal to minus 500 to plus 500, d less than equal to plus 500, d plus plus. So now I am on minus 500 difference. And with this difference, I'll traverse each value from 0 to n. And what I need to check, that whether any value I got with the current value minus difference before. So let's say my current value is 5 and my difference is, here I got this d as 2. Okay, and this nums of I is 5. So what I need to check, like, is there any value 5 minus 2 which is 3 present? Is there a 3 present? If yes, what is the length until that 3? If the length until that 3 is x, then the length until that 5 will be x plus 1. Right? Because until 3 will be calculated with this difference only of 2. Right? So what we will do? We will store this values to our map, to an ordered map. I'll take an ordered map of int comma int, okay, which represent this as your nums I. So with my current nums I, what is the value? Length. Okay, what is the length if I'm taking that particular, and I'll do 1 plus that length. Initially everything will be 0. Okay, so now let's say I have reached 5. So what I'll do, I'll check for map of 5 minus 2, which is map of 3. Did I got map of 3? Yes. Then I'll put map of 5 as maximum of map of 5 comma 1 plus map of 3. So my map value is nothing but starting from value 1 to n with all differences possible. All differences existing in my array. That only will be get stored. Not every difference like 6, 7 and all. It will store only those which are present. Let me had a clear idea with the example. So we have 1, 2, 5, 10 and 15. Okay. Now let's say I'm currently at difference is equal to 3. Okay. Now difference is equal to 3. Okay. Now with the 1, do I have map of 1 minus 3 present already? Map of minus 2? No, not present. Map of 2 minus 3 minus 1? No, not present. Map of 5? No, not present. Okay. Now when I'm at 10, I have stored my map of 5 as, if it's not present, I got this everything. I'll make map of this particular difference, whatever I'm getting as 1. Like, okay, map of 5 is 1. Now I reach the 10. Okay, like here also I'll make map of minus 2 as 1. Map of 2 minus 3, which is minus 1 as 1. So I'll get minus 1 by difference of 3. Okay, for each of this difference I'll clear my map. So I'll initialize my map for every difference. For every difference. Okay, so now my this map is related to this particular difference of 3 only. When this difference will be 4, I'll clear my map and I'll make a new map, or I could say I'll clear that map. Okay, now 5 I got like 1. Now with the 10, so like 10 minus difference of 3. Oh, I have to take difference as 5, right? I'll take difference as 5. So 1 minus 5 minus 4 will be stored, and 2 minus 5 minus 3 will be stored. Okay, and 5 is not present. Okay, 5 minus 5 is 0. So I'll store map of difference 0 as 1, which is not present. Okay, or map of 5 is 1 only, sorry. Every number is currently present with the value of 1, with the length 1. Now 10 minus 5 is 5. Now is there map of 5 present? Yes. So I could take either map of 10, which is 1, or 1 plus map of 5, which is 2. So this become map of 10 became 2. Now with the 15, 15 minus 5 is 10. And our map of 10 is 2. So this became 1 plus 2, which is 3. Okay, let's solve it and you will get the better idea of what I'm trying to say over here. Okay. Okay, so I'll share this tab. Fine. You have in 10 as nums.size. I'll make one unordered map. Okay. Now, your initial answer could be 2. Your minimum of minimum answer could be 2. Now, here you'll be given reference again minus 500 to nums of I could be from 0 to 500. So, difference could exist from minus 500 to 500. So, for int difference is equal to minus 500. When difference are less, we can do this approach. Okay. What I'll do, I'll clear the map. I'll go from I0 till I less than n. What I'll do map of nums of I is equal to maximum of map of nums of I 1 plus nums of I minus difference. Okay. Now, we'll not check whether nums of I minus difference is present or not in the map. Okay. If it's not present, it will take this value as 0 and it will automatically assign value 1 to map of nums of I, which we are doing. Okay. Cool. And every time I'll do answer as maximum of answer comma map of nums of I. And I'll return this answer. Now, with this any difference, there is another question with a particular difference. Like with the particular difference only you need to find. And of course, your one loop will be saved. You only need to run this loop with the given difference in either question. Okay? I hope you got it. Now, in the next video, we'll see some miscellaneous questions, or I could start with another playlist of 2DDP, whatever is feasible for you. Stay tuned, stay safe until that. Do like, share, and